In this video, we're going to go over how to distribute radicals, square roots. Let's check it out. So we have the instructions to simplify. We've got the square root of 2 times the quantity, root 6 minus root 5. This screams, use the distributive property. And then we'll see where that lands us. So just distribute the square root of 2 to each number, here and to there. So that's going to be the square root of 2 times the square root of 6. I'm going to show you what I'm doing out mentally, over the minus sign, root 2 times root 5. Beautiful. So now that we're there, it's up to us to now simplify each of those expressions. So if you're having trouble with multiplying radicals, square roots, check out my earlier videos on how to take the products of square roots, how to multiply them. So the square root of 2 times the square root of 6, you could reduce that to the square root of 12, or you could notice that root 6, and I like doing it this way, is root 2 times root 3. Doing that allows us to reduce right away. The square root of 2 times the square root of 2 is 2 root 3. Now I'm going to point out there is nothing wrong with you doing the square root of 12 and then reducing that like we know how. All right, I just did it this way. Here, 2 and 5 share no common factors at all, so when we multiply them, the answer is going to be in simplest radical form with no perfect squares, minus the square root of 10. 2 times 5. They're not like radicals, so we're done. It's in simplest form. The name of the game here is use the distributive property and then see where each individual product leaves you with your old school multiplying skills of radicals. Okay, 5 root 3 times root 3 minus 2. Again, we are going to distribute. 5 root 3 times root 3, I'm going to write that out, even though you might be able to look at that and do it mentally. More on that in a second. 5 root 3 times minus 2, so it's minus 5 root 3 times 2. Okay, we'll go piece by piece now. Root 3 times root 3 is 3. So you're going to end up with 5 times 3, which is 15. Minus, the 2's on the outside of the radical already, so we multiply 2 by 5, which is 10 times the square root of 3. We can't combine them any further. They're not like terms, so we know we're done. Mentally, some people will look at this and say, root 3 times root 3 is 3. Times 5 is 15 and get right to here. That's the way I do it now. 5 times 2 is 10 with the negative. Root 3 is on the outside because it didn't get multiplied by anything. So some people, and I hope you're some of those people eventually with enough practice will get there and skip a lot of those steps and still be just as accurate. As you advance in math, you're going to want to learn to be more efficient like that so that all that work doesn't get in your way. But for now, we got to put in the work to understand the foundations. Then you'll get fast with it mentally. Okay, again, we're going to distribute root 6 times root 3 and times 2 root 5. So I'll show you mentally what's going on. Root 6 times root 3 plus root 6 times 2 root 5. Okay, so we have distributed the square root of 6 to both terms over addition. Now, again, I'm going to do this one differently than I did this one. Here, you could split it into root 3 times root 2 and simplify it, or you could rewrite it as root 18. I'll do it this way now. Plus, and we'll go here, root 6 and root 5, I'm going to multiply those two. 6 has no common factors to 5, so we know that, and there's no perfect squares in either of them, so when we multiply them, 30 is going to be the simplest radical form, and 2 is on the outside. Root 18, however, can be reduced into 9 and 2, 9 being the largest perfect square that goes into it. Square root of 9 is 3, so we have 3 times the square root of 2, plus 2 root 30. 30 has no perfect square factors. None of them go into it evenly, so we knew 30 was in simplest radical form, and this cannot be combined because root 2 and root 30 are not the same thing. That's it, peeps. That's all we've got as far as simplifying with the distributive property involving radicals.